heating effect of electric current and its practical application. So in the previous video, we saw that heating effect of electric current means heat is generated when electric current is flowing through a conductor. And we saw Joule's law of heating. Joule's law of heating, which says the heat generated in a conductor is given by I squared RT. So it is directly proportional to the square of the current and directly proportional to the resistance and directly proportional to the time for which the current is flowing through the resistance. So this we called as, this is the Joule's law of heating. So this Joule's law of heating have a lot of practical applications, and some of the applications where we use it is electric iron, toaster, electric toaster, then electric oven, heater, kettle, electric kettle, and so on. So in this session, we'll be looking at two particular applications. One is the electric bulb or incandescent bulb. So in electric bulb, heating effect is used to produce the light. So heating is used to produce light. So we use a special coil known as filament, and this filament is made of tungsten. So what happens is when electric current is passed through the filament, it will get very hot and it starts emitting light. So when electric current flows through filament, it gets hot and produce light and emits light. So since this filament is going to get very hot, right? So because of that, we should use a material that has high melting point. So tungsten is used because it has high melting point. High melting point. So the melting point of tungsten is about 3,380 degrees Celsius. And because of that, it doesn't melt easily. And that is why we can use tungsten. And the filament is thermally insulated and it is kept inside a chamber where it is filled with chemically inactive gases. For example, argon or chemically inactive nitrogen. Nitrogen gas is filled inside the bulb. So to summarize, we can say for electric bulb, heating effect of electric current is used to produce light, And for that, we use a special element called tungsten, and it is used as the filament of the bulb. So when electric current flows through the filament, it gets hot and it will start emitting light. So tungsten has high melting point, and since the filament should not melt while heating up, we use tungsten. So the melting point is around 3380 degrees Celsius. And for avoiding any other chemical reaction, we'll be filling up the bulb with an inactive gas like argon or inactive nitrogen. So that's about the electric bulb. So let us see the next application which is the electric fuse. So the next important application of heating effect of electric current is electric fuse. So we know that fuse is a safety device. So it protects the appliances from excessive current flowing through it. So excessive current flowing through an appliance will cause it to be damaged. So we use electric fuse. So what does it do? It protects, electric fuse protects the circuit and appliances by avoiding excessive electric current. Excessive electric current. So because of that, we use the fuse in series with the device. So if we have a device, for example, let's say a heater which can be represented by a resistance R. So if you have a device, this is our device. So we'll place our fuse in series with that, because so that we can cut off the supply if there is excessive current. So let's see how it works. Fuse is placed in series with the device. It consists of a wire. It consists of a piece of wire made of a suitable alloy or metal. So this particular metal or alloy should be having the required resistance, or it should be appropriately sending the required current through the circuit, and no excess current should not be permitted. So this could be aluminum, copper, iron, lead, etc. So depending on the application, depending on the current requirement. So what happens if a current that is larger than the specified value flow through the circuit? So the fuse material is selected in such a way that if the current is excessively flowing, then it will melt. So the fuse melts if an excessive current flows through it. So this melting happens because of heating effect of electric current. The temperature of the material will increase and then it will melt. So when it is melted, the circuit will break. Circuit will break and the device can be saved. From excess current. So that is the use of electric fuse. So it has a suitable wire which will melt if an excessive current is flowing through it. And since this fuse is connected in series with the device, the circuit to the device with the device will be disconnected. So let us see one example. So for example, if we have an electric iron and it has a rating of 1 kilowatt. So it consumes 1 kilowatt 220 volt. That means it consumes a power of 1 kilowatt or 1000 watt in when connected to a supply of 220 volt. So it consumes 1 kilowatt when connected to a 220 volt supply. So we can say the current, we know that P is equal to V into I, or we can find out the current flowing through the electric iron. I is equal to I is equal to P by V. So what is the power? It is 1 kilowatt or 1000 watt divided by 220 volt. So we get a value of current 4.54 ampere. So this is the maximum current that will flow through that electric iron. So this is the current that should flow through the electric iron. So here in this case, we can use a fuse of 5 ampere. A 5 ampere fuse can be used, so that it will allow a current that is required, but it will not allow more than that. So 5 ampere fuse can be used along with such a heater. So fuses are available in different rating, like 1 ampere, 2 ampere, 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. So we saw electric fuse as well as electric bulb. These are two applications of heating effect of electric current. I hope the topic is clear to you. Thank you. We'll meet you in another session with a new topic.